now we are going to find what is the gain at resonance. At resonance, I denote the gain by ARES. At resonance, when omega equal to omega naught, delta will to 0. So I denote A resonant equal to, put delta equal to 0 here. So you will get all the terms except this last term will be only RT. RT by 1 plus 0. So it will be RT. See here, A resonant equal to minus GM into this term into RT. Now find the ratio. What is A by ARES? A is this entire term and ARES is this term. So when you divide A by ARES, only this term 1 by 1 plus J2 delta QE alone will be there. All other terms will be perfectly cancelled out. It is a complex number, so take the modulus, find the magnitude. The magnitude of A by ARES equal to 1 by root of real part square plus imaginary part square, 1 square plus 2 delta QE the whole square. And the angle is tan inverse y by x. Tan inverse 2 delta QE by 1. It is numerator, the angle is 0. So 0 minus tan inverse of this angle. So it is minus tan inverse 2 delta QE. Here you will have a minus sign because it is coming in the denominator. The angle for numerator is going to be 0. 0 minus tan inverse 2 delta QE. So resonant frequency, the ratio of gain will be exactly equal to 1 by root 2. Okay, that is what we are substituting. Numerically, it is 1 by root 2. Logarithmically, it is going to be equal to 3 dB. So while finding the bandwidth, we always draw a 3 dB line from the maximum value of gain, right? That is in logarithmic scale. But now we are working in numerical scale. We have not taken log or we have not used the term logarithm anywhere, right? So as long as we have not used that, we have to equate that to 1 by root 2. So equate this term to 1 by root 2. So equate this term to 1 by root 2 to find the bandwidth. Okay, so at resonant frequency, there are two frequencies, bandwidth omega 1 and omega 2. Omega 1 is called as the lower cutoff frequency and omega 2 is called as the upper cutoff frequency. So at frequency omega 1, which is the lower cutoff frequency, so delta is going to be 1 by 2 into QE. Then this term will be equal to 1 by root 2 or 0.707. And it is the lower cutoff frequency. Similarly, at the frequency omega 2 above the resonant frequency, delta is going to be 1 by 2 into QE. And same way, the ratio will be equal to 1 by root 2. So at the cutoff frequency, the power, the gain will be 1 by root 2 times the maximum value. If you say in terms of logarithm, it is going to be 3 dB lesser than the maximum value. And bandwidth is given by omega 2 minus omega 1. Delta omega equal to omega 2 minus omega 1. So I am adding and subtracting omega naught to this term. I am also multiplying and dividing by omega naught for simplification. See, listen very, very careful. Omega 2 minus omega 1 term, I am adding and subtracting omega naught. And I am multiplying and dividing by omega naught the entire expression. And if you rearrange, you get omega 2 minus omega naught plus omega naught minus omega 1 into omega naught by omega naught. So omega 2 minus omega naught by omega naught plus omega naught minus omega 1 by omega naught. Whenever you find the difference, it is going to be delta. So the first term is going to be delta. Second term is also delta. So delta plus delta into omega naught. Remember, we have written the formula for delta. Delta equal to omega minus omega naught. Omega minus omega naught divided by omega naught. So wherever you find difference from omega naught and divide by omega naught, that will be replaced by delta. See, first term omega 2 minus omega naught by omega naught, it is delta. Second term omega, it should also be omega 1 minus omega naught, right? No, because omega 1 is less than omega naught, so the expression will slightly change. It will be omega naught minus omega 1 by omega naught. That is also equal to delta. So delta plus delta into omega naught, or it is 2 delta into omega naught. So the bandwidth is going to be 2 delta into omega naught. Omega naught is going to be the resonant frequency of your tuned circuit. And we know delta is equal to 1 by 2 QE. So 2 delta will be 1 by QE. So substitute here. So delta omega equal to omega naught by QE. Very, 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 very important derivation. So we have found out what is the bandwidth of the tuned amplifier. Bandwidth equal to omega naught by Q. Or in terms of frequency, if you write bandwidth delta F is equal to F naught by Q.